Let's talk about Chapter 18, Section 1. This is rates of reaction. One of the things that you need to think about anywhere you see the word rate is basically speed, or how fast something takes place. So if we're looking at rates of reaction, we're looking at things that affect how fast reactions take place. They don't all occur at exactly the same speed. So the first thing that we're going to talk about is temperature. Temperature is one of the most common things that can change how fast a reaction takes place. Usually raising the temperature will increase the speed. As you know, temperature is a measure of kinetic energy or speed. So if you increase temperature, you increase the speed that the particles are moving, and that makes them hit each other more often and with greater energy. And I have a little visual for you here. We have a reaction at 30 degrees and a reaction at 40 degrees. Now, if I make both of them move, you can see that the one on the right at 40 degrees is moving faster than the one on the left. That's causing them to come into contact with each other more often, and they're hitting each other harder when the little circles actually manage to bump into each other. So the one at 40 degrees would take place more quickly. Another factor to consider, if I get back to it, is concentration. Concentration is just the amount of substances that you have. If you increase concentration, it means basically you have more stuff. So if you increase the reactants, you put more of your starting ingredients together, the reaction should happen faster. And the reason, again, is because you'll have more collisions. The particles, because there's more of them, will bump into each other more frequently. So there's a little visual on this one. If you look at the one on the left, I have, I don't know how many of these little yellow dots, but I have about twice as many of them over here on the right-hand side. And so when I make this play, what's going to happen is those little dots are going to move around, and they come into contact with this little marble chip at the bottom. And if you look at the little hits over here as they're kind of highlighted at the bottom, you can see that the one on the right has a lot more hits than the one on the left because there's more little yellow dots to kind of bump into it. The concentration is greater, so this reaction on the right would take place faster. Another factor is particle size. Particle size is literally the size of your particles. Now this one kind of is counterintuitive. If you decrease the particle size, you make the particles smaller, you actually increase the rate of the reaction. The other ones have been, like a directional increase. So if one goes up, the other goes up. This one's actually backwards. If you decrease the particle size, you increase the surface area and you increase the reaction rates. Basically, when you increase the surface area, you make the reactants come into contact with each other more frequently. And if you've noticed the pattern, what makes all of the reactions go faster is increased contact. Anything that you can do to increase the contact of the particles will make the reaction happen faster. And so for my last animation, we have this nail here. And so for the first one, you have this nail that is coming into contact with these little blue dots. And right now, the only part of the nail that can come into contact is the outer parts. And if you watch it happen, you'll see that none of the nail in the middle gets touched by the blue dots because, well, it's surrounded by the outer pieces and you can't come into contact with them. And then in just a minute, we're going to switch over and we're going to break the nail up into some chunks, and we're going to make more pieces of the nail. So if I go ahead and advance one more, you'll see the same nail broken up into pieces. Well, now we can also access these pieces that were in the middle. You're going to get increased contact with smaller pieces, so the reaction is going to take place more quickly. The last thing to look at is the definition of a catalyst. You are expected to know what a catalyst is, and you talk about this lots in biology and AP Bio classes. A catalyst is something that makes a reaction go faster because it lowers the energy that you need to start the reaction. Basically, it just kind of makes it easier to get going, and we'll look at it in a little bit in another couple of sections with some actual graphs and diagrams. But, an example I put on here was that the digestion of proteins in your body at body temperature at 98.6 degrees Fahrenheit would take years if you didn't have catalysts in your body to make it happen. There's also something called an inhibitor. An inhibitor, it inhibits, it stops something. It basically will stop a catalyst from working, and there's a biological explanation to this, but one of the examples is like if you put lemon juice on a cut apple. Y'all know that when you eat an apple and you bite into it, the apple turns brown. It's because there's a catalyst that's in the apple. When it comes into contact with the air, it actually starts doing a chemical reaction and it turns the apple brown, and if you put lemon juice or anything acidic on it, if you change the pH of it, it will inhibit the catalyst and keep it from working. You just simply need to know like that a catalyst lowers the energy and an inhibitor is something that will stop it. That's all for this section, and you need to make sure you've taken notes on this and then go to the second video.